Algebra 2, Lesson 26, Trinomial Factoring and Overlapping Right Triangles. We're going to the practice. We'll be doing all 4 practice problems today, A through D, and we'll be starting with A, trinomial factoring. So the first thing to remember in trinomial factoring is to always write your trinomial in descending order. So descending order would be the highest exponent to the left and the lowest exponent on the right. You should usually end with a whole number or whatever value has the lowest exponent. From here, we're going to go ahead and write our 2 sets of parentheses, and then we look at our first term. Our first term is an x squared, which is what we're looking for. If our first term is x squared, we can go ahead and put x in x, because first times first will equal x squared. From there, we go to our signs. All right. Now, if the last symbol is a negative, then that means our signs are going to be opposites. All right. So we've got that down. Then we go to our last whole number, which is 7. And 7 can be created by multiplying 1 and 7. It's a prime number. That's all we got. So using 1 and 7, is there any way we can get these two numbers add up to -6? Absolutely. Put 7 there, positive 1 there, and we've got it. That's it. So remember those steps and remember how they work as we keep going. Now, this one, it looks like it's in descending order, and it's got an x squared term, so you would think we can go ahead and start factoring it, correct? Incorrect. The problem is this first term has a negative. The first term, in order for us to begin factoring this trinomial, has to be a positive x squared. It's not. It's a negative. So we have to factor out a -1 out of the entire trinomial. So that turns it into x squared minus 6x minus 16, because once you take out the negative, all the signs change. From there, we can go ahead and factor into our 2 sets of parentheses. Since we've got an x squared term in the lead, we can go ahead and put our 2 x's. The last sign is a negative again, so we've got a positive and a negative sign. And now we look at 16. So what times what will we'll multiply to 16, but then add up to -6. Well, we could try 4 and 4, but if we do -4 plus 4, that's going to give us 0, so that's not going to work. Let's try 2 and 8. If we use 2 and 8, we could get -6. We could put 8 there, we could put 2 there, and then we've got -1, 2, yep, we're done. That's it. So as long as these 2 numbers multiply to that number and then add up to that number, we're good. Now the last one gets a little more tricky. We've got some high exponents, and then it's not in descending order, so we'll start by writing it in descending order. First, to put it in descending order, we have -3x to the 4 plus 21x cubed, and then plus 24x squared. Alright, so now it's in order, but then our first term is very, very far from x squared, so we got to pull out a greatest common factor. First, we're going to pull out the coefficient of -3. We already got that one down, but then how do we get the x4 to turn into an x2? Well, we just pull out how many x's there are that prevent it from being 2. So if I take 2 x's away, I've got x squared. So our greatest common factor is going to be 3x squared. And then I can pull 2 x's out of each of these. So if I divide each of these by 3x squared, that becomes x squared. Or sorry, -3x squared. That becomes x squared. That becomes -7x. And that becomes -8. So now I've got this new polynomial to work with. So let's go up here. So we'll factor this up here. We've got -3x squared, x squared minus 7x minus 8. And we'll start breaking it into our 2 sets of parentheses. So we've got our lead term of x squared. The last sign is a negative, so our symbols are going to be positive. Let's get rid of that exponent. It's just x and x. We'll have a positive and a negative. Now the last number is 8. We have to find a way to add up to 7 but multiply to 8. That's pretty simple. It's going to be 1 and 8, -8 plus 1. And so our answer is -3x squared, x plus 1, x minus 8. Now, practice D. Right triangles that are included inside of each other. And we got to find missing pieces. So we're going to use proportions again. And then we also have to be careful of this hypotenuse side and this leg down here, because again, this whole side is a plus b. B is not referring to the whole side. A is only referring to this section. B is only referring to this section. So when we set up our base proportion, we have to figure out what side we can relate to the other. If we go to the bottom, we know that this base of 4 will relate to the overall base of 7. So that's going to be our base ratio. We're going to do everything in terms of 4 to 7. Now, as far as relating sides, we can quickly figure out 5 and c using ratios. But then we'll run into some trouble with a and b, and we'll get to there eventually. So when we go to 5 and c, 4 is to 7 as 5 is to c, cross multiply to solve, and then we get 4c equals 35. So divide by 4, and c equals 35 over 4. Now, when it comes to solving for a and b, we're kind of at a standstill because we can't relate a to b without knowing one of them. However, if we look at this right triangle, we see we can use Pythagorean theorem really quickly to find a. So a squared is just going to equal 4 squared plus 5 squared. It's 16 plus 25, which is, let's see here, 41. So a squared equals 41. A equals square root of 41. So now we have a value for a. A equals square root 41. And then we can use that to solve for b. Now this proportion is going to get a little wonky, so make sure you pay attention. So we're going to use this original ratio, 4 to 7. That's the small to the big. The small is going to be square root of 41. That's going to be equal to a plus b. So square root of 41 to the overall side of square root of 41 plus b. So remember, this denominator becomes a polynomial, so when we cross multiply we have to distribute, so we get 4 times the square root of 41 plus 4b equals 7 times the square root of 41. From here we'll subtract 4 root 41 from each side. And the cool thing is these are both like terms, so 7 minus 4 gives us 3. So 4b equals 3 times square root of 41. Last thing we'll do is divide by 4 on each side. So then b equals 3 times square root of 41 over 4. And then we've got answers for all of them.